A very good afternoon, ladies and gentlemen. Thank you for tuning in. Hope you are having a pleasant day. It's great to be back again this week with another episode of the Strata Talk Show. With that, I would like to welcome everyone to the 33rd episode of the Strata Talk Show, brought to you by the Excel Academy of Real Estate. In this talk show, we'll be discussing issues and cases related to the management of stratified developments with various industry professionals. Joining us today, we have Mr. Kuan You Wai, Director at the PKN Building Solutions Sendihan Berhad, to speak on the topic of maintenance of concrete structures based on EN1504. If you have any questions for Mr. Kuan, feel free to leave them in the comment section below, which will be addressed in the Q&A section at the end of the show. Without further ado, join me in welcoming Mr. Kuan. Welcome, sir.
Thank you. Thank you. I hope you can hear me clearly. Okay, my name is Kuan. I'm Thanks for the invitation from Excel Academy. Okay, we'd like to start the presentation now. This session of presentation is to help the audience to understand uh, why concrete need maintenance over time. It was not deemed, as robust as before. So I hope everyone can hear me clearly. Can I have some comments? If you can hear me clearly. Okay, I'm a speaker on interflow leakage. I'm also a speaker on EN1504 for Institute of Engineer Malaysia, crack prevention and remediation measures for leaking wall and cracks for Institute of Engineer Malaysia as well. Advanced building inspection for a conference organized by JKR and UM jointly. And I also speak about defect management in stratified building for Royal Institute Surveyor Malaysia. Also, I'm a drafting committee for CII S7 about QLASIC for the latest version. Okay, why we are talking, pertaining to the repair and maintenance of concrete structure based on EN1504. In fact, there is a good reason to it because it's recommended by KPKT, and it's a national standard for the Britain and the European nations, which approach concrete maintenance in a holistic and scientific method, approaching it from multiple disciplines, including corrosion engineering, and it address root cause for the optimization of life cycle cost and durability. So this is the brochure published by KPKT pertaining to the recommendation for the EN1504 in the diagnosis and repair of concrete structure, penyelenggaraan bangunan strata. Okay, in fact, beside EN1504, which you can see clearly that it was only launched in 2009. So it's a pretty new knowledge. Okay, and thereafter, American and Australian try to catch up. America community under American Concrete Institute launched 562 in year 2016, and the Australian community launched their guide in concrete repair in 2018. So this is really a very new knowledge that has been being promoted globally due to the fact that concrete is not as robust as what we thought used to be. So here, let me tell you a story about concrete. Okay, the history of building, where people start to live in the cave, start to build timber structure, and start to build taller and taller building with the innovation of cement. And with the use of reinforcement steel bar, the building keep going higher and higher. But the progress eventually encounter some problem, and this problem, after investigation and debate in the different levels of authority, eventually become regulation that certain concrete structure must be able to hold the load, must be safe. The practice must be safe, and the building must be able to be fire resistant. So, what is concrete? In but then the concrete, okay, is actually known as artificial stone. Our ancestor used to build with natural stone. They cut the natural stone into the size that they want, into the shape that they want, and they assemble it. But modern industry, we don't use stone in that manner. Instead, we use concrete. Concrete is a mixture of air, uh, the cement, fine sand, aggregate, as well as water. When it is hardened, it has very good compression strength, but very weak in tensile strength. So when you compress, it is very strong. But when you pull or when you bend it, it is indeed very weak. It cracks easily because of the brittleness. So how to counter this? The way we counter this is by use of reinforcement steel bar. Reinforcement steel bar is strong in tensile. Okay, so when you pull, it can resist the pulling to such a huge level, depending on the hardness as well as the iron content and the carbon content and the size. It actually can take different uh, tensile stretches. So that's why when we combine concrete with high level of compressive strength with reinforcement steel bar with high level of tensile strength, it becomes so strong. Strong in a way that it doesn't become brittle. It can actually flex a bit without being deformed. So that's how we get concrete structure, reinforced concrete structure, which is high in compression as well as tension by the use of concrete and reinforcement steel bar. So why concrete and reinforcement steel bar is used widely? Actually, as compared to other material like pure steel or pure stone, it is much cheaper. Secondly, it is readily available because the major component of concrete is sand, aggregate, which is the stone. In Malaysia, we have granite stone of high quality very easily, and then the cement, which mainly comprised of limestone, which is also easily available and not expensive. It is fire resistant and it actually expand and contract identically in a way that I will elaborate later. And the high level of alkalinity actually protect the reinforcement steel bar against corrosion. Now, this is what I meant, coefficient of thermal expansion. The concrete is between 7 to 12, 10 to the power of negative 6, okay? And the steel is 11 to 13, 10 to the power of negative 6, coefficient of thermal expansion. So it actually, when it is heated or when it is cold, it actually expand and contract in a similar rate. That's why it can work perfectly. And the high level of alkalinity in the concrete derived from the use of calcium carbonate or the limestone actually give a layer of protective layer. We call it free radical layer. Sorry, passive layer, passive film that protect the reinforcement steel bar against corrosion. So these are the like brothers who are so well aligned to each other. Okay, so when we design concrete structure, of course we have to know the strength of the concrete matrix, the concrete masses. Okay, then the use of rebar, where will the tension force be, and we need to counter it with the good number or sufficient number of reinforcement steel bar with the correct sizings and placement. And then we have to construct design our structural elements with the correct size because of the load transfer. And I would like to show you what is the load transfer. Load transfer from the rooftop down to the pillar, the concrete slab, or the horizontal beam. Uh, it also have that load that will be transferred to the pillar. And then the lower the pillar go, the more strength it have to take. So the pillars at the basement is the biggest as compared to the pillar at the rooftop. So this is how building structure actually design and transfer the load. So depending on the solidity of the soil, the profile of the soil, then maybe piling will be required if the soil is soft to hold the building, vertically, in order to bear all this type of load that is transferred from the top to bottom. So, okay, we come to talk about the EN1504. EN1504, the most important part is the part 9 about the principle of using different method to repair concrete. uh, Principle 7 talk about different technology. The one talk, principle 9 talk about the principle 7 talk about the method, and the testing method is also discussed very thoroughly. Okay, in the product that is in compliance with EMR 504, they will have a CE tag, showing that which company is from, which part of the EMR 504 it actually comply with. Okay, so this is the tag that you will normally find if the repair material is in compliance to the EMR 504. So let's talk about during construction, what will go wrong? Okay, firstly, the first photo is segregation, whereby due to over vibration, the paste float up, the aggregate go down due to over vibration. Okay, the second one at the bottom is it is the spacer that make the reinforcement steel bar to be in a correct position, because in reality, after this type of BRC mesh is laid on the concrete slab, worker will walk around and it will try to press it down. So when the uh, reinforcement steel bar is not in the correct position, after being pressed down or being kicked away or messed up, then the property of the whole design will go haywire. And thirdly, about this slump test, it actually talk about the water and cement ratio. Water and cement ratio play a very crucial part in the strength of the concrete. So it must come with the correct ratio, and at the site is not mixed by any water. So meantime, if we use the wrong type of aggregate, that will expand in the event of or in the presence of water, this is what we call silica aggregate erection. That the concrete will crack by itself so badly that it will disintegrate by itself. And in the presence of salt, corrosion will also, if the sand come from the seaside, which contain salt, then the concrete itself will disintegrate so fast, so rapidly, that the reinforcement steel bar will start to corrode, even though with very minimal presence of water. So of course, when a car or machine hit the concrete, it can also be damaged. And the presence of water, this is the deterioration after service lifespan. Okay, so when people already start to occupy the building, so this type of presence of water can also cause the evidence of efflorescence and differential settlement. If a natural settlement, where the building eventually settled down in the first 10 years, this is normal, except some of the utilities underground will be compressed and be broken. If the building rotate evenly, it's still not so bad. The worst thing is some part is strong, some part is not strong. It's called differential settlement. This type of settlement will cause diagonal crack. Okay, and of course, in area of the septic tank or the STP, the production of acid by bacteria, as well as the presence of hydrogen sulfide, can also erode the concrete very fast. Uh, Unauthorized loading at the bottom, is this will also cause a lot of crack. Different type of crack have different implication, which I will elaborate later. But natural type of shrinkage due to the evaporation of water. Water actually comprise 30 to 40% of our concrete originally. So when the water evaporate, it will shrink naturally, and such shrinkage will be evidenced by the natural shrinkage crack like this, which have no structural concern, but it need to be repaired. So building is built to separate our internal environment with the external one. So the issue is our environment as compared to UK environment, whereby our Portland cement originated, whereby our building design originated, is very different. So BS 8110 is the design code for the design of concrete structure in Malaysia. But our the BS 8110 is designed based on the situation in UK. Back in Malaysia, our intensity of rainwater, intensity of heat is so intense, so extensive. That's why it creates a lot of problem to us. And with the arrival of climate change, things is even worse lah, due to the heavier rain, stronger wind, and worsening heat wave. So heat-induced crack is a major issue in Malaysia. Even the Masale in UK, they realize that heat is a problem to them. But in Malaysia, whereby is in the tropical rainforest climate, wow, this heat is even more damaging to us. And this is actually the mechanism, the horizontal, upon the exposure to the heat, the horizontal flat roof expand. And at this photo, we can see the slab is being heated up. When it is heated, it will expand and it will cause a lot of crack at this part of the vertical wall right under the flat roof. So this, in fact, it expand and contract every day. From a primary study done in University Malaya under Dr. Zahiruddin, we know that at 1:30 p.m. the average heat on the flat roof reaches 82 degrees Celsius, and at 4 a.m. It can go down as low as 17 degrees Celsius overall in average. Okay. So another issue that we have in Malaysia nowadays is earthquake. After the Aceh earthquake in 2004, the landmass in Malaysia is no longer earthquake free. As a result, the building code known as MSEN 1998 has been included in the Uniform Building Bylaw. It will The impact is in future all our new building must be earthquake resistant. However, what about our existing building? It need to be retrofitted, to be strengthened. And this is actually a photo in Bukit Tinggi. Back in 1990, back in 2006, if I'm not mistaken, there were 13 earthquake range. The the magnitude is around 3 to 5. There were 13 earthquake between 2006 to 2007 in Bukit Tinggi, whereby the epicenter is in the Peninsula Malaysia. For your information, beside Bukit Tinggi with the highest risk of earthquake in Malaysia, the second highest risk is Center Kuala Lumpur. Manjung, Kuala Lipis, and Kenyir, those are the area also with some level of earthquake risk. So I would urge you to look into the earthquake retrofitting that to salvage your building for the activated or the reviving seismic activities in Malaysia. As for the East Malaysia, this especially Sabah, Ranau, and Kudat, Sandakan side, they are known to be very active nowadays. So uh, I'm still working out with the different municipal hall to update them pertaining to this standard, together with Professor Aslan Adnan. And due to the uh, due to the climate change, our groundwater is also raising. I have discovered more and more leaf pit fill up with groundwater nowadays. And in basement, the chemical content in the groundwater actually can determine how detrimental it can be. So, okay, I will show you more info later. Beside sulfide, sulfide from the combustion of petrol and from the hydrogen sulfide in our uh, STP and the septic tank, as well as the hot spring, actually can disintegrate concrete chemically in this manner. So sulfide is also another issue. And from the different standard, EN1504, ACI 562, and the Australian standard, it has been well recognized unanimously in consensus that uh, corrosion is the biggest headache of concrete. How corrosion can affect the concrete, we'll come to it in more elaboration later. But basically, in a nutshell, it's an electrochemical process that in the reinforcement steel bar, due to the fail or the how to say no the ineffective protective protective layer of the high level of alkalinity, uh, then corrosion can start. I will elaborate in further detail shortly. Okay, and the corrosion. In, the original size of the reinforcement steel bar can be 10 mm. Upon full level of corrosion, it can expand up to 6.5 times of original size to up to 6.2 mm. So the stress actually come from inside the concrete. And once the corrosion matrix is formed, once the corrosion cell is formed, even though we waterproof the concrete, the corrosion activity will slow down a bit, but it will continue, cracking the concrete from within continuously. And carbonation is one of the major cause of corrosion. Carbonation, okay, our rainwater, upon the exposure to carbon dioxide, it will form carbonic acid. Carbonic acid, it will neutralize the concrete. The original pH of concrete is 12 to 13. It can bring down the pH of concrete to lower and lower. When it reached 9, when the carbonic acid neutralize the concrete up to the pH of 9, and when the carbonic acid reaches the reinforcement steel bar, then the corrosion will start. It will crack the concrete from inside, and eventually you will see something like this, you know, in your dam concrete area, in the presence of chloride, which act like as a catalyst or mungkin dalam bahasa. It actually accelerate the corrosion in a much faster rate. And this type of chloride is actually found in marine environment and swimming pool. Do you know our swimming pool has actually chlorinated in order to maintain the water quality? But the chlorine in the water is so detrimental to our concrete. And for your information, the first two slices actually come from below swimming pool. Okay, and the third photo actually come from marine environment in a pot. And how fast the water, the corrosion can start, it really depends on how impermeable your concrete, the porosity of your concrete. Of course, the more porous it is, the faster water can travel. So, and then that make the concrete cover. The concrete cover is actually the distance between the reinforcement steel bar to the surface of concrete. It's known as concrete cover. The thicker the concrete cover, the more durable it is, because it will take longer time for the concrete to go through. In marine environment or in swimming pool, we actually need to add additive to make the concrete more solid and dense. So these are all special requirements for different for this type of structure exposed to chlorinated water. And this is how it actually. If you Google for, if you go to YouTube and start to type concrete corrosion, you will have a video animation that show that once the once the chlorine ion started to infuse into the concrete and reaches the reinforcement steel bar, it will start to cause corrosion to be triggered, and the corrosion, the byproduct of rust, will crack the concrete because of the uh, increase in the volume. Once the concrete is cracked and then eventually pop, you will see the rusty reinforcement steel bar on your structure element. And there's something that a lot of people is unaware of is stray current. Stray current, stray means liar, okay? The current that is not intended to be this, I mean, infused into the ground due to the presence of MRT or LRT that use direct current as their electrical supply, direct current. This type of direct current uh, can cause a lot of corrosion into the nearby foundation and underground pipe. This has been studied and evidenced in North America many years ago, but I came across a corrosion engineer who told me that in Malaysia, our railway also use direct current, and we are not sure if any assessment has been done on the corrosion risk of this electrical system. So there's something that I will write to the authority pertaining to this thing. Okay, so now we talk about how pillar fails. For your information, pillar take a lot of load. Any abnormality on the pillars is not acceptable. Beam. Not all type of crack is dangerous, but I would like to show you a few type. Okay. Firstly, the type of crack that go through in the first image. From top to bottom. This one need to be taken care of. Need to get a structural engineer to enter. Okay. The type of second type of crack under here, the second photo, this is fractural crack, which is not as dangerous, but it need to be repaired because the diffusion of carbon dioxide into the concrete is it will trigger carbonation. So any crack must be repaired. Okay. Uh, for your information, of course, CO2 can go into the concrete, can infuse into the concrete easily at the slightest crack. But for the water to be able to travel in, it only needs 0.23 mm, which is equivalent to the size of your hair, the thickness of your hair, for the water to be sucked into the concrete, simply because there's a lot of mineral in the concrete. The mineral will pull in the water through osmosis process. And of course, corrosion risk, corrosion crack, which happen along the reinforcement steel bar, because once the reinforcement steel bar start to expand, it will crack the concrete cover, which is the thinnest surrounding it. So it typically can be seen along the reinforcement steel bar in a very clear pattern, and this is also dangerous. The most dangerous one is shear crack. Shear crack can collapse anytime. It the crack actually happen uh, from the front and the back. It actually extended all the way through from the tension zone to the compression zone. This type of crack can collapse anytime. I urge you to look into this type of crack and get your structural engineer to come in for an assessment. Okay, let's talk about how what is the strategy that we can have when we encounter deformation or dilapidation of concrete. First of all, if I design the structure to be 30 years, something like a warehouse, and in the 25th years, it have a lot of problem. Actually, I don't need to do anything, because in the after some years, I will demolish it. So one of the option is do nothing. Second one is, of course, you need to analyze, or you need to prevent, or you need to strengthen, or reconstruct, or demolish it thoroughly. So there are six strategy to it. When it come to, okay, the one that I put star actually need further diagnosis. Okay, so these are the way of diagnosing crack. First of all, we measure the crack line. Anything more than 0.3 mm on the structural element, it's not on the surface. I need to remind you that even though we see a pillar, we need to remove the cement script on the pillar to measure the crack on the concrete itself, not the cement script. Okay, so this is something that we need to be aware of. And based on BS 8110, anything larger than 0.3 mm on the structural element, if it happened on your pillar, that is even more severe. If it happened at the lower part of your building, the pillar in the basement is even more severe, okay, than the one above. So it all depends on the location and if it is a primary beam or secondary beams, things like that. So it all depends on the load that it carry. In order to check the concrete, the propagation of crack inside the concrete, one of the way is to use ultrasonic pulse velocity, use the wave method, the sound wave, is something that like the ultrasound emitted by the bats. So in engineering, we also use that the same principle, known as either echo impact or ultrasonic pulse velocity. Besides, we can also use endoscope to look into what is inside the crack. Once there is delamination or crack, any diffusion of water into the concrete or any air into the concrete, it can be identified easily with infrared imaging. So the first photo show that the infrared imaging on the wall, and the photo at the bottom here actually show the infrared imaging for the flat roof. So it can be identified based on the understanding of infrared and the property of water. Rebound hammer is an in situ method to detect to to find out the compression strength of the concrete. But the weakness is it always gives higher reading, about 50 to 60% higher reading than what it actually possess if you do a coring and send it to the lab for compression testing. Simply because when we hit on the concrete, sometimes we hit on the concrete with reinforcement steel bar right below it. Okay, so the more correct way is we use scanner to identify where is the reinforcement steel bar, and we only use our rebound hammer to measure on area without reinforcement steel bar, okay, or in between two reinforcement steel bar, so that we can get a more accurate reading. Okay, so this is how we did it at site. And of course, to detect where is the reinforcement steel bar, the number of them, the size of them, we can use ground penetrating radar, which can come in a handheld form, very handy nowadays. Wall scanner or concrete cover meter. Our cover meter will show me the concrete cover thickness, the thickness of the concrete cover. So as I said, concrete cover is a indicator of durability, which I have explained just now. And the carbonation level. Phenolphthalein liquid. Uh, okay, I have some here. This is phenolphthalein liquid. Okay, this phenolphthalein liquid, if I spray on the concrete, anything with pH less than 9, it will become transparent. pH more than 9, it will become purple in color. So I can see exactly what is the depth of carbonation. And of course, the most important part is have the carbonated concrete reach the reinforcement steel bar. So this is a very convenient and economic way. And of course, we can measure the chloride content of the uh, different, specimen from different depth, uh, based on uh, a standard called 433 433 accelerated penetration of chloride into hardened concrete, which I have got the machine. Uh, we can also use different specimen to measure the pH of concrete. The higher the pH, the more alkaline the pH, the more healthy the concrete. So the lesser or the more acidic the pH of concrete, the concrete is at higher risk of corrosion. And of course, we can take the specimen, take the core, and send it to the lab and use the high precision uh, microscope to see what is happening into the concrete, known as petrographic imaging. Okay, this is what we have done in one of the hospital in Seramban. This is actually the actual work that we have done. And in terms of corrosion, because corrosion is a electrochemical process, that's why we actually can use a voltmeter to measure the corrosion risk, based on this diagram. And then we can map out a different location, which location have the highest risk, and to see how bad has corrosion happened. Okay, and of course you can send the water sample for pH uh, test for E. coli. If the water come from waste pipe, it have E. coli. If the water is highly acidic, maybe due to the peak soil underneath the building, then your building is in big risk. So and of course you can see some of the component in the water sample can be corrosive as well, see, like hydrogen sulfide, dissolved gases, dissolved oxygen. Uh, okay, so it's just like doing blood test. Instead of cutting meat and check, we can do blood test or urine test, right? It's actually identical to doing water tests, water lab tests. And when it comes to the principle, there are a few principles, seven or nine. I will go through it shortly. The first principle is to stop the water. Second principle, to stop the moisture. Third principle, concrete restoration, is to do non-structural repair. Principle 4, structural strengthening, is to do structural repair. Principle 5, improve physical resistance, is to prevent the infuse of water and carbon dioxide into concrete. The principle 6, resistant to chemicals, is of course to resist the infuse or the diffusion of chemical into the concrete. Principle 7, or there are 11 principles. Principle 7 is to restore the passivity of the concrete. So instead of pH 9, how can we improve it to pH 11 or 12? So this is a restoration of pH. Okay. When it comes to principle 8, we talk about resistivity. Resistivity is another way to say corrosiveness. Okay. So cathodic control. How can we stop the activity or the corrosion activity at the cathode and at the cathode part of the corrosion cell? Okay, and cathodic protection is how to use direct current to infuse electron Bear in mind, corrosion is a process due to loss of electron. So how can we replenish the electron back to the reinforcement steel bar so that we can stop the corrosion? And principle 11, how to stop the corrosion activity at the anode part of the corrosion cell. So this is pretty much chemistry, in nature, which a lot of structural engineer is not aware of. So, but uh, I would like to urge you, if the structural engineer is not aware of, please always remind them, because corrosion engineering is a subject in chemistry or material science. It's actually not a subject in structural engineering. So I urge you to beware of this. Okay, let's come to repair strategy. How to stop water. You can either use coating, repellent, or impregnator. Okay, as shown in this photo. What is the difference between repellent, which is, another word is hydrophobic impregnation, and coating? Is actually how is a different. They actually have the different when it comes to resistant to chemical, carbon dioxide, and water. So you can see some of them can resist water as well as carbon dioxide. Impregnation can only resist uh, water, but some level of carbon dioxide can go through. And for impregnator or hydrophilic impregnator or repellent, water can be repelled away, but carbon dioxide will still go in. But meantime, it is also breathable, whereby the water inside the concrete can breathe out, and you see the water can go into a round shape like this. And okay, when it comes to another way to block the water, of course you can have cladding, you can have torch membrane, or you can have single ply membrane. Uh, but I would like to bring to your attention, because of the nature of heat on our flat roof, white color type of membrane like this, which is permanently elastic, is very suitable to the to the flat roof in Malaysia, as compared to torch membrane. Torch membrane, it have a layer of stone chips on the surface. It's black in color, and it actually is very good in absorbing heat, and the heat absorbed through the torch membrane cause further expansion to your reinforcement slab, the concrete slab. And as a result, the stress due to the expansion will crack the whatever waterproofing or torch membrane on the surface. As a result, there are few papers that says that torch membrane is not suitable for tropical. Single ply membrane is more suitable. And of course, water will flow through the crack. So one of the way is to fill the crack with epoxy on the condition the crack is the static type of crack, maybe due to natural shrinkage. Okay, then epoxy can be considered, but epoxy is not heat and ultraviolet stable, so it cannot be done on an area that is exposed to the weather. Uh, for any type of dynamic crack, flexible sealant is actually more workable and more effective. PU grouting, I personally don't recommend unless it is caused by natural shrinkage. Okay, and bandaging is actually a very useful way. Using We actually use elastic type of membrane, like for instance the single ply membrane like this, to bandage the crack, just like the bandage that we put on our wound. Okay, so of course, when it comes to non-structural repair, say due to honeycomb or due to impact, we can patch back. The patching back is very important because it restores the strength I mean it improves the resistivity to the infusion of water as well as the carbon dioxide. Okay, this is how we patch. Okay, you can use spray concrete. We can patch with towel, or for some simple structure, we can even use formwork, to make to expedite the work. And okay, structural repair. So bear in mind just now, crack is a major way that the concrete uh, fail. Okay, crack. Maybe due to unauthorized loading. Okay, so there are a few ways to rectify to do concrete repair. Actually, concrete strengthening is taught in structural engineering syllabus. So structural engineer is very well aware of this. Okay, for carbonated concrete, we need to remove the concrete. We need to remove up to the bottom of the reinforcement steel bar and cast it with a new concrete. Okay, or we can increase the size of the existing pillar by adding another layer of reinforcement steel bar and cast another layer of concrete. Okay, we can also use steel plate uh, to increase the strength of the beam, or fiber carbon. Meantime, this type of work, a lot of time we need to do anchoring like this one. Okay, we use epoxy, specially designed epoxy that come with structural strength to do anchoring that can can which can enable us to design either additional thickness or additional beam. Okay, so of course we can also use epoxy to glue back the concrete, but all this must be done by a registered structural engineer. Anything with structure must be designed and supervised by structural engineers. Bear in mind, okay? Don't simply trust the contractor who are not who have little knowledge about this, and do the concrete repair by yourself, because the liability is beyond your level, even beyond my level. Okay, so I would like to ask question now. In this type of chipping, which the edge of the concrete pillar is chipped from top to bottom. Some of the old method in the 60s to 70s say that we should use limestone, lime mortar to repair it, simply because it's breathable. But studies show that it typically fail within 10 years, because the lime mortar doesn't have the structural strength to help to share the loading of the load that transfer from the top to bottom. So, or should we use concrete of similar strength to the existing pillar, or should we use buy from the Sika or Mape or whatever the company uh, to use high strength mortar to repair it, or should we strengthen the pillar? Actually, this question I ponder upon this question for quite some time. Okay, first, if we use limestone mortar, it have no strength to help to take up the to share the loading capacity. If we use high strength mortar, the load will go to the small portion of the new high strength mortar, and the high strength mortar is too tiny to take the load. If you use something of the similar strength, well, because it have already failed, if you use similar strength, it will soon fail again, right? So, in fact, we need to strengthen this pillar, So it all go to the analysis that we have to go through, and please let the competent person do it. Let the structural engineer do it, because they will sign on it and they will take responsibility to their design. So, okay, let's say basement or the lift pit or the underground chamber. When water come in, one of the way to solve it is actually drill hole through, pump in chemical to the back of the structure, and let the chemical expand and form one layer of impermeable skin to protect the underground structure. But I actually have a lot of doubt on this method because in Malaysia, I can see water pressure is so high, in this type of situation, I really have some my reservation into it. But again, let the competent structural engineer handle it. Okay, don't do it by yourself. Don't simply trust your contractor. Instead, get a structural engineer in. And of course, this method, when the concrete start to bend, we can use tie or cable to hold it back. This is called post tensioning. So this has been applied very successfully in the highway near to Kepong. Okay, you can see this method under the bridge, under the flyover in Kepong area. And of course, if we apply coating, PU coating, epoxy coating, this repair strategy can reduce the diffusion of carbon dioxide into the as well as water into the structure. And of course, another way is increase the cement screed. So when you increase the cement screed, of course, the water and the air cannot easily diffuse into your concrete. So okay, we come to principle 5: how to preserve or restore passivity, how to return the pH of concrete, which has gone down due to the diffusion of carbon dioxide or carbonic acid or chloride. Okay, one of the way the contaminated concrete to be removed and replaced. Another way is, of course, increase the cement screed thickness. And if we can use liquid and with very small molecular size particles, we actually can diffuse in the high level of alkalinity to the concrete by way of gravity. This has been done very successfully by a lot of Germany company, and yeah, we also can do this um, based on our technology in Malaysia. So by way of diffusion with highly alkaline liquid. And I would like to bring to you electrolysis of water. This is what we were taught in our secondary school, right? Whereby if we use an anode and cathode, connect it to a battery, uh, the water can be segregated to O2 and H2, hydrogen gas and oxygen gas. With the same method, if we apply it to concrete, whereby the positive side is connected to the titanium or platinum mesh, the negative side is connected to the reinforcement steel bar, and we use a direct current to inject in electron. Similar reaction will happen in the concrete. Okay, whereby the water will be segregated into OH negative. Oh, sorry, OH negative, yes, and then the hydrogen gas will be diffused off. Okay, so this is one of the way to increase the pH of or the alkalinity of the concrete. And of course, by controlling the voltage, we actually can cause the chloride, which is negatively charged, to move away from the reinforcement steel bar. If we charge the reinforcement steel bar to the negative charge as well, because negative charge and negative charge, it will push each other away. If the voltage is energized to a higher level, higher voltage, even the H positive, even the chloride gas can evaporate to the air, to the atmosphere. But there is a regulation to it, but I would like to share with you. Okay, titanium mesh and platinum mesh. Titanium and platinum are precious metal. If we want to put one layer of titanium mesh or platinum mesh onto our concrete, it will cost a bomb. No one can afford it. Okay, so this method it worked in the lab, but can hardly be applied, especially when our currency drips so badly. Okay, another way to control corrosion. Corrosion control is to apply anti-rust, to apply corrosion inhibitor like this one. From my own research and checking, I discovered this is the more feasible way, which only costs a fraction from the cathodic protection technology, but it it actually can stop the corrosion activity either from the anode side or the cathode side. It can retard the corrosion activities, and it can even stop the chloride to be activated, depending on the chemistry of the corrosion inhibitor. Sacrificial anode and impressed current, I'll come to it shortly. Okay. Now, different metal, when we attach together, the metal which is more reactive will sacrifice and oxidize like this. Okay. So let's say our steel is ferrous. If we attach it to aluminum or zinc, aluminum and zinc will oxidize. As a result, the steel is protected. It will stop corrosion. This is some of the cathodic sacrificial anode that we can find in the industry. How it is attached to the uh, reinforcement steel bar, and of course, impressed current, whereby we inject direct current with the similar principle of electrolysis of water. Any loss of electron will be replenished back by the direct current with the injection of new electron. So, in conclusion, when we consider all this corrosion control or concrete strengthening, there are so many options. What we when we need to choose them, we need to know what is the failure mechanism first. Okay, we also need to know how feasible it is when it comes to dollar and cents, and of course, what is your expectation when it comes to safety and the service lifespan? And because each of the method have their pro and cons, we actually need to use in combination so that we can achieve what we want to achieve. When it comes to the rehabilitation of the concrete, and of course, when it comes to quality control, we have to do random checking. We also need to do document all the steps, and finally, this is the last part of my presentation. You can Google for my blog or my articles in iProperty platform, or you can contact me if you have any question. So I pass it back to you, the organizer.
All right. Thank you so much, Mr. Kwan, for that insightful talk. Now we'll be moving on to the Q&A section, where hopefully you will enlighten the audience on any questions they have on today's topic. So for our first question, we have a question from Wani Rose. Um,
Funny, ayo.
yeah,
Okay.
in terms of leakage and dampness issue, what kind of standard or industry practice that we can refer to?
Okay. Be frank to you. Malaysia Uniform Building Bylaw have a section 84 which talk about preventive measure of dampness, but it is so brief in a way that uh, suitable measure must be designed and constructed. How suitable is very subjective, because we don't have a clear guideline. And in CIS 7, the description is also very, very vague, whereby uh, any leakage which can be visually detected is not allowed. But a lot of leakage cannot be seen by naked eye, So it's actually another contradiction and very, very vague things. And for your information, um, I am trying to develop a Malaysian standard for waterproofing under CIRIM, which is uh, on the way. We need to consider Malaysia climate as well as our way of using water in our house. Masale, don't shower like the way we shower because and their weather is actually drier. So as a result, they actually have a practice of dry toilet, and dry toilet actually don't even need waterproofing. But if our house in Malaysia don't have waterproofing, is a disaster with the mold growing, with the paint peeling. Oh goodness! I have seen houses, new houses that the architect did not design waterproof for the toilet in ground floor because to them they thought we use a dry toilet method like the masale, which is not the fact. So that's why it caused me to have the urge to go through all the hazard to develop the standard for Malaysia, and hopefully please pray for me, I can make it in my lifetime. Okay, so there's what I can answer you lah. So what a consumer can use uh, fitness for purpose if it leak and you need to defend your right, you need to understand that any dampness is detrimental to us in terms of concrete structure as well as the health, because the excessive dampness can cause a lot of mold to grow. So yeah, there is the issue lah. When the mold come, biological contamination, people have asthma will have asthma attack regularly. More asthma attack. People that don't have asthma eventually will develop asthma.
Mm.
Okay, so any other question?
Great, sir. Moving on to the next question. We have a question from Mizadi. What are the steps in selecting a repair procedure?
Okay, I would urge you urge you to bear in mind. I have seen periodic report. Okay. Oh yeah, I would like to highlight to the audiences as well. In the event that you have any doubt that your structural integrity have some abnormality or deformation, sign of deformation, please trigger periodic inspection under Street Drainage and Building Act Section 85A to contact the Building Control Division, Jabatan Kawalan Bangunan, to write to them that you want an earlier periodic inspection. First, the periodic inspection come in two stages. Visual inspection. If you really have problem, the engineer will specify the non-destructive testing method that I have discussed just now. The Kawalan Bangunan will help you to go through the proposed method for non-destructive testing or further analysis. And if they really think that you need it, then they will return you a letter saying that, yeah, you should do it. And the second stage of inspection must be carried on. The rationale for doing you see, is if you have got your periodic inspection done earlier, in the time that your building reached 10 years or 20 years or 30 years, when the local council write to you for a periodic inspection, you actually can show this letter to them that we have informed you that we want an earlier periodic inspection, and we have done it accordingly, and we have complied to all the recommendation recommended by the engineer for further analysis and repair, and the engineer have certified our repair. So all this, when the next letter come, you actually don't you are actually exempted from the requirement for periodic inspection because you have done it earlier. So you after your earlier inspection, you have another 10 years to go, for the next one. So it will save you money and save your building against any doubt of deformation or damage. So the rest of the thing, let the structural engineer to go through, but always bear in mind, remind them who are, some I have already briefed some of them in IEM, that corrosion is an issue, and corrosion is not taught to them because, as I have shown you, the standard is new. the standard hasn't go into their syllabus yet. And the old school or the old batch of structural engineer, some of them even told me, "Hey, Mr. Kwan, if you don't tell us chloride is so detrimental, we don't even know chloride actually exists in our swimming pool, you know." So yeah, bear in mind, if the structural engineer don't know, you being a building manager, please remind them. And of course, you can come to seek my advice lah.
All right. Great, sir. For the last question we have for today is by Mr. Carson Chin.
Okay,
What are the possible decisions after finding a structure to be inadequate?
so it depends on the cause of inadequacy lah. If it is not strong enough, it can be strengthened. If the corrosion start to happen, it can be controlled. You know, if the tensile strength or the compression strength have dropped to a level that is risky, you know, it can be salvaged with the correct implementation of repair based on EN1504. So I hope I have answered you. And in the event if you have more questions, you can always go to my iProperty platform or my blog for further answer. Most of what I want to tell you is all written, you know, there. Then you can access it at, at a time convenient to you at any location, you know, worldwide.
All
Actually,
right,
my
sir.
blog has been read quite widely
Mm,
from the reader in North America.
I see.
So don't know, because English is my third language. As you can see, I don't speak very fluently, but because of the my proficiency in English, I can only write in layman term. And being layman is very very welcome by a lot of general public lah. That's why perhaps
Mm.
that's why my articles has been read widely. And iProperty actually told me my article in Interflow Leakage is reaching 100,000 reader. You know.
Oh, wow.
It become a blockbuster in iProperty.
Awesome, sir.
Okay. Any other question? Or
I believe that's all the question we have for today. So we have reached the end of this talk show. With that, I would like to invite everyone to the Strata Conference 2022, Strata Management Trends that will shape 2023, happening on the 29th of November in Hotel Armada, Petaling Jaya. So for those who are interested, you may scan the QR code displayed on the screen as well as visit our Excel Academy of Real Estate Facebook page. All right. Once again, I would like to thank Mr. Kwan for sharing his insights today, and as well as all the participants for tuning in. Uh, yeah, we hope to see you in the next one. Thank you.
thank you, thank you.